I'll wait for some more folks to stream in. I'll give it a minute or two here. Do anybody have any questions before I get moving here in a bit? Okie dokie. Well, I will get moving then. 3:32, so about on time. Okay. Like prior, the last couple homework assignments, right? This one is a template-based assignment. You're just going to fill in a few things. So this homework assignment uses cleaner, easier to work with data than the previous one. It's kind of nice, simple Pronto data. But what's tricky about it is sort of getting the data loaded in and doing sort of basic working with it because it's going to be in sort of a different data structure. So first thing I'm going to do here is I'm going to download the template for this. I'm going to go ahead and say save link as. I'm going to throw it into any old rando folder, which will work, in which case I'm going to throw the same one as I've thrown all the rest of the labs in so far this term. Then I'm going to download the data, which is a fairly large file here. Right click, save link as. And I'm just going to huck this in that same folder. Say it's about 70.8 megs compressed. Uncompressed, it's substantially larger. If you don't have a lot of hard drive space on your computer, this may have come as a surprise. It's really taking a lot longer than it should. Okay. Okay, what I'm going to do here is I'm just going to unzip this to, let me make sure. Okay, yeah, unzip this to Open Data Year 1. There we go. And you'll see Open Data Year 1 here ends up being about 850 megabytes. So this is a pretty large one. There's one file in here responsible for most of that size. It's this 2015 status data. We're not actually going to use it. If you're low on hard drive space or anything, or later on, just remember to delete this file. I'm going to leave it in so I can show subsetting files and directories and stuff. But basically, all the size is actually due to the status data file, which we're not going to use. Okay. Now I'm going to go ahead and open up the template. Okay. And we got something like this. If you have any problems downloading and opening the template or downloading the files themselves, let me know and we'll try and resolve that. Okay, November 23rd, 2020. Okay, so this homework assignment is using the Pronto bike share data from the old doc style bike share, the Pronto system. So if you've been on campus as long as I've been on campus, you probably remember the little docked bikes that were around UW campus and elsewhere in Seattle. If you haven't, you might not know what I'm talking about, and that's fine. So basically, this is just a bike share system where, unlike sort of like those line bikes and Uber bikes and things that have been around, these bikes had to be picked up at specific docks you lock the bike into and checked out from them. So they're basically point-to-point systems. So the idea here is we're going to load in all this data on individual bike rides, and we can use it to sort of draw essentially usage map, not geographical maps, but plots showing like the day-to-day traffic going from one station to another station, or at least traffic coming in and out of specific stations. We'll get there next week. This week is mostly focusing on just getting the data in and doing a little bit of cleanup. Okay. So, supposed to just boilerplate up here. An important thing, which I did a second ago, is you will want to take the data out of the zip file, and I would put it in a open data year one folder, and the folder should be in the same directory as the RMD file we're going to work with. It's a lot more annoying to deal with it if it's in some folder way off elsewhere on your computer, and you'll have to use specific file paths. It's always nice to use the data in the same folder as the RMD or in a subfolder in the same folder. Okay, so basic idea here is we're going to try and load these data in with a couple different methods, and we will do both methods to load these data. And actually, we'll do 3 methods. I'll also show you the vroom method, but it's so trivial that it doesn't really count as showing you anything. So the first thing we want to do is load these data in using a loop. Okay. So these instructions are pretty specific here. So I say, make sure the Open Data Year One folder is in the same directory as this template. I've done that. You should do the same. And then use list.files on the Open Data Year One folder to return a character vector giving all the files in the folder and store it in an object called files in year one. Okay. So if I want to do that thing that the text says right there, what should that look like? Not a trick question. I like the look of that. Let's see what that does. I'm going to grab that straight out of there. So files in year one, list files, open data year one. If I look at files in year one, it's going to say I have 2015 station data, status data, trip data, weather data, and a readme.txt. Okay, so this looks to me like the contents of the Open Data Year One folder. So this code does exactly what we wanted to do. Okay, so the next thing here is I want to modify this statement right here and say I want to use subsetting on files in year one to remove the entries for readme.txt because it's not a CSV file. We're not going to use it. And also remove the status data, which is a really huge file that contains nothing of interest. Okay, so if I wanted to take this vector of text here and remove those two things, how could I modify this line? I don't need to make a new line. How could I just modify the one I have? There's a million different ways to do it, but there's one trivial way. I like the look of that. What we could do is we could use subtractive subsetting and remove elements 2, the status data, and 5, the readme.txt. So I'm going to go ahead and do that. I usually like doing it like this. I say I want to subtract and then elements 2 and 5. It should be the exact same thing to do it either way. Yep, that does the job. I'm going to leave it this way. It's one less minus sign, and I'm a particular type person. But yeah, that'll do it. So what this says is take list.files open data year one, which looks like this, but remove the second and the 5th element. And that takes us down to the 3 that we care about. Are there questions about that? It's tools from week 4. Yeah, so are you worried about subsetting by index in general? In general, yes. I generally don't like subsetting by index in case anything else is ever going to get added to it. But it's easy here. In almost any other sort of situation, I would definitely probably not use index subsetting. So would you like to see another way to subset these things out that doesn't use the index? I can do that. Do you have an idea how that might happen? Ah, beautiful. So this is saying excluded are going to be those two files, and then not in. Yeah, so that's exactly one way you could absolutely do that. So here, what he's done is he's taken a vector of the files he doesn't want and then said, here's these files, but do not include these particular ones. Okay, that's exactly, I mean, this is the same result of essentially the other way to do it. The way that I would do it, and would probably occur to me sort of first to do it, especially if the other files might be added, would be to take the list.files here, and then I would say, it's not string remove, it's actually, I want to string subset those ones, and I would say, give me everything, see, that does not match this. Well, that's a reverse lookup. There's should be an inversion for string subset. Neg8 equals true. I would say, give me something that matches either status or readme. Oh, I haven't loaded a package, so this isn't a stringer. So what this says right here is go into list.files open data year 1, search for the word status or readme in all caps. And normally if I didn't have neg8 equals true, it would say keep only these. But in this case, neg8 equals true says drop only these. The end result is the same thing. We're going to get into string subsetting like this on Wednesday, which is why I said there's some tools here you could use to solve these problems I haven't taught yet. But in this case, you know, this is fairly complicated and isn't necessary, but it'll do the job. Okay. And that's sort of the way that I would normally do it. I try not to do index subsetting like that. Okay, so when I do list.files open data year 1, it returned character 0. Not sure why that's so. Your open data year 1 folder might not be in the same folder as your RMD file. So if you just do list.files like this with no text in it, it'll show you everything in your current working directory. If you run that and you don't see open data year 1 in there, that's why. That might also be the case if you haven't unzipped the file yet. So in my case, the open data year 1 is a zip file. If you haven't yet unzipped it to a folder, you might also get that. So it's probably one of those two things. That work for you? Yeah. Yeah, and we don't have to move particularly fast in today's lab. So normally, I will probably end up writing a grand total of like 20 lines of actual code in this thing to solve the first half of the homework. So we can take our time on things if you get stuck. So one of those ones that'd be very easy to spend a lot of time writing code, but if you know how to set these things up and do them, it's actually quite fast. And learning that stuff is why you're all here. Okay, so keep chunking along. I'm gonna clean up and get rid of this. This isn't hurting anything, so I'll leave it there. Okay, so now what we want to do is the hard part of this. We want to read the remaining .csv files into data frames stored in a list called data list. And I straight up tell you how to pre-allocate this so you don't have to remember it. I can just take this code here and put it like that. What this code says here is I want to create an object called data list. I'm going to assign to data list a vector of type list. This is how you make lists. And I'm saying the list is going to be of length equal to the length of files in year one. Well, files in year one is a 1, 2, 3 length 3 character vector. So data list here, if I create this, should be a empty length 3 vector. Okay. I have created an empty, not vector, but list, a length 3 list. That's all I've done. Okay. So the next thing here, we would like the names of the list entries, that is the names of the elements of that list, to be simpler than the file names. Basically, the file names are things like 2015 _ station data.csv. I would rather have this be just station data. Similarly, 2015 trip data.csv, I would rather have this be just trip data. Okay. So I could do this all in one step, but breaking it into parts makes it clear what's going on. So I'm saying here, you should make a new vector called data list names, giving the names of the objects to be read in these CSV files using files in year one. I say you could use the string sub function in Stringer to do this. You could do it without string sub technically. Yeah. So I'm saying here, and I'm quite specific, let's take the entry starting from the 6th character, which drops the 2015 part, and stopping at the number of characters of each file name string -4, which drops the CSV. And we need to load Stringer also. So what is this going to look like? What's the first thing I got to do here? I'm holding hands a little bit more than usual in this homework assignment because the actual loop writing can be traumatic for people. Okay, so here's some code here. This says we're going to create some data list names. I'm going to assign to that the result of string sub on files in year one, start at the 6th character, and end 5 from the end. Okay, what's going to happen when I run this line? Is this going to work? All right. So I got that error message, right? What do I got to do first? Load Stringer. Exactly. So I'm going to say here, load Stringer. Then I run that. Now we see data list names is station data, trip data, and weather data. Okay. So what this has done is it's begun with files in year one, and it's started, it's cut these down. What it's done is said, this is element 1, 2, 3, 4, 5, 6. So it begins at S, right? The 6th one. And then it goes until 5 from the end, which is 1, 2, 3, 4, 5, this one. So it's gone from here to here. And the nice thing is that works on every single one of them because we always want to get rid of the first 4 or the first 5 and the last 4. So here's an actual question here. Why do you need the L? In this case, you don't. But if you're sort of somebody who's a stickler for programming conventions, the L here specifies that it is an integer 6 and not a numeric 6. In R, it doesn't really matter in this case, but sometimes people like to be specific. In fact, the help file, I wouldn't be surprised if they use an L. Yep, start 1L, end 1L, because people like to be specific that it's that kind of a data type. But as you see in the sort of examples, people actually don't use it in practice too often. Here, it doesn't matter. It does nothing. Okay. So the next one. Are we using string sub to avoid regex for the moment? Yes, exactly we are. Any idea why something will run in the console but not in the chunk in the RMD? What is the error message you're getting? Because in general, that shouldn't happen. Does it return character 0? Like it says literally like that? No, empty. So which things exactly is return? Oh, so this is returning empty. Like this is
Yeah, it's actually the first line of code we did, and I can run it in the console, so I don't want to hold anyone back. But if I run it in the chunk, it'll show that the character is empty.
Okay, so running this, like just this part of it right here, if you put that in the console, you get something that looks like that.
If I run in the console, it works. I get the actual list.
Mm-hmm.
But if I run it in the chunk, it says character parentheses empty.
Character parentheses empty?
Yeah.
That's an interesting one. Yeah. So just like you highlight this and you run it in the chunk and you get character empty here. Okay. So what do you get if you just do list.files like that in the chunk?
I just get the name of my RMD file.
Okay, but you don't see the open data year 1 or anything?
Right.
So your data are not in the same folder. The open data year 1 is not in the same folder as your RMD.
Oh, right. It's in my RMD is in a subfolder. That's the problem, I think. Okay.
So yeah, you want to make sure that the open data year 1 is in the same folder as RMD, or you could browse to it. If the RMD is in its own subfolder, you could go like this, period to browse up a directory, and then / and then into open data year 1, and assuming open data year 1 is in a subfolder in the same folder as the subfolder your RMD is in. Does that make sense?
Okay, that was my mistake. Thank you.
Yeah. Okay. Like it. Okay. So question in chat. You can technically leave off the start and stop, right? Yes, you actually absolutely can. So here it says start equals 6, end equals that. But because the arguments to string sub are the string you want to subset and then start and end, so we provided them in the same order, we can remove them and it would work exactly the same way. However, you could, if you do them this way and you name them, you can put them out of order. So it really depends which one you want to remember. Do you want to remember the arguments themselves and not their order, or remember the order of them? I do both, depending on the situation. So the next one, what do stringer substring and string subset do respectively? So substring goes into the individual strings themselves and cuts them down into smaller pieces. So basically, by saying string sub 6 to 5, I'm actually going to reverse that so it's clear. Makes more sense to go start first and later. This basically says start at the 6th character, keep everything until the 5th one from the end. String subset, what string subset does instead is add or remove entire entries from this vector. So if we go to the original like files in year 1 or all the folders here, string subset would say here, find the one that contains the word status or the one that contains the word readme and remove them. And then the thing you end up with is 3 long. So one of them is getting specific words inside of them, but it doesn't change the overall length of the output. This one actually changes the length of the output, but it doesn't modify the text itself. Yeah. Does that make sense? Hopefully. Okay. So another thing that we could do, sort of, if people ask, I'm going to do it. We could do this with regular expressions instead, which is what we're going to do actually on Wednesday. So instead of saying begin with the 6th character and end with the 5th, we could instead do this. I could say, let's make data list names equal to string remove and cut out the things I don't want. I'm not asking people to fill this one in because I have no expectation anyone knows how to do this. And I'm just going to say, let's remove anything that matches from the beginning of the text to 2015 underscore or .csv. I think I got to do, / to the end of the string. Do I need double slash? Yeah, I need double slash. Okay. And that would also do a thing. This is a thing called regular expressions. So if you really want to work with text seriously in any programming language, you want to learn regular expressions. And so I'm going to force you all to learn them on Wednesday. Regular expressions are one of the most important skills for text manipulation a person can learn, and you literally will not survive doing data programming without them if you work with text. They are, however, their own independent little logical language, which is neat because if you move to some other programming language, it doesn't matter what, it's all basically the same thing. You learn regex anywhere, you go somewhere else, you can use them there too. So here's a great question. What does the double slash mean? This is where it gets a little weird, and we're going to go into it on Wednesday. This is actually the slash in the regular expression says this period over here, I actually want to search for a period. If you don't put slashes in front of it, period means any character. So I have to put a slash in front of it. The thing is that slashes are a reserved character in R, so I have to tell it that I actually want a real slash. So I do that by escaping that slash. So I'm saying, use this slash to tell R that I want this actual slash, and use this actual slash to say I want this actual period. This is stupid, and we're going to get into it on Wednesday. So it's okay for it to be a little bit confusing. Yeah, regular expressions are complicated, but they're worth learning. They're one of the most useful and powerful things out there that you can use for general data programming. Anyway, I just had to show you this. Don't expect to understand it. If you do understand it, you're probably ahead of the game. Anyway, I'll brush over it. Okay, we're going to spend too much time on our Wednesday. So the next thing we've got, now we have our data list names. So I'd like to set the names for data list using the names function and this data list names vector. How do I do that? How do I assign names to something? Okay, like the look of that. So now what needs to be plugged in here? Yeah, data list is going to go over here. So if I highlight this, you'll see data list right now doesn't even have any names because data list looks like this. 1, 2, 3 null, just sort of like locations. So what do we need to assign to it? Give it some names. Yeah. If I do that, data list now looks like this. So instead of being those like subsetting brackets we saw before, now the first element is station data, the next is trip data, the next one is weather data. And you'll notice it's changed from being double square brackets to a $sign. It's just its way of sort of telling you you can now use $sign subsetting to get station data, trip data, or weather data if you want now. Okay. Had trouble with these names as I went along. Later operations erased them and I needed to reassign. So we'll see if that same thing happens to us, but it probably shouldn't. So normally what would cause them to disappear would be if data list itself got overridden or replaced. And as long as we're operating sub elements, that shouldn't be a problem. Okay. So yours looks like a vector and not a list. So your data list here, so if you run just data list, it looks like a vector and not like this.
Yes, it looks like a list.
Oh, it does look like a list?
Well, my data list looks like a list, but then when I try to create this new names data list, it looks like a vector again.
Well, names data list will be a vector like this, because those are the names of the object, which will be a character vector.
Okay, okay, right. Thanks.
Yep. Yeah, so you should now have something that should look exactly like that. So I'll leave up there. Okay. Anything holding anybody up? I don't see any other questions to catch, I don't think. Because now we will go to the traumatic part. Okay.
Sorry, can you explain a little bit about what names function do here?
Yeah, absolutely. So this is sort of an odd thing, right? This is an operation which you get used to, and you don't even think about it when you assign names and get names from things a lot in R. But when you really look at it, it's actually pretty weird, because what we're doing is we're assigning something to a function, right? This function names data list. It's like, wait a minute, what are we doing here? This is a weird thing. So that's a good thing to catch. So the names function, so for instance, if I do names data list, it produces the names if I just run names on here. But the thing in R is that a lot of operations in R are symmetrical. If you can extract something, you can also put something in using the same method. So for instance, if I say something like data list 1, this gives me the first element of data list. There's nothing actually there right now. But remember, I could assign something to it like that. And now data list in its first element contains a big number like this. Oh, this is actually just like assigning something to names list. This bracket here, this is a function for subsetting. The funny thing is the names function is also a function for subsetting. What it's doing is it's subsetting the names attribute of an object. The names attribute is sort of metadata. It's basically like the columns in a data frame are its names. And this is just a function that lets you subset and get that element of the object you're working with. Right? It's actually just like the bracket type subsetting, but it just looks like any other function in R. Does that make sense?
Yeah, thank you.
Yeah. Yeah, I'm gonna delete that, rerun the previous stuff. There we go. Okay, wipe it back. Okay, so next one, the tough part. So what we're gonna do is we're gonna write a for loop that uses read CSV from the reader package to read in all the CSV files that were in the zip file. We're going to sequence along the files in year 1 vector to do it. You could do it in other ways, but that's the way we'll do it here. And we're going to grab each one of those files and store it in its corresponding entry in data list. Okay. I say here, and you don't actually have to, we're going to use cache equals true chunk option for this chunk. That way you don't have to keep loading the data in every time you knit it. And we'll want to make sure to use read underscore CSV. It's a little faster, it's a little bit better. It's not critical, but we can. Okay, so there's a lot of different things we can do here. What would be one of the first things we could do? It could be anything up in any of these instructions. What should I do? I like that. Let's load up reader. I'm going to say we'd like to use the reader package. So we've loaded up the reader package. Okay. So check that off. What's another thing we want to do? It's a few different things. we could start writing the skeleton of our loop. We could add a chunk option that I mentioned we want to add, any sort of stuff. Sure. So this is something what we haven't actually visited too much. We haven't been messing with chunk options too much recently. But if we say here, cache equals true, this will make it so that this really only runs once when we knit it. And when we knit it in the future, it doesn't have to run it again. It actually will rerun it if you change the code in the chunk. Okay? I actually highly recommend you don't use cache equals true unless you only put something in there that's like loading data or running a model. Never ever load libraries in a cache equals true chunk, because the next time you run it, it won't run that chunk, but it won't have the library loaded because it doesn't run the chunk. So you have to be careful. Sometimes weird errors will pop out. Yeah, cache equals true can sometimes be dangerous. I advise not using it unless you got a really good reason. Okay. In this case, it's an example of a case where we might want to. Imagine we're loading these files in, but they were hundreds of megs or thousands of megabytes. Cache would make them load a lot faster. Okay. So next thing, if we want to run a for loop to load our data in, how would I start that? Oh, we got a whole structure here. Let's begin with this. I like this. This is great. I'm going to just copy paste that in and we'll work with this. Okay, so see some red text. It's grumpy about something. It's probably a bracket missing. I can already see. I'm going to go ahead and add that little bracket there. Okay, so there's already a lot of code going in here. So I will sort of walk through some parts of what's going on here, and before I run it and test it, right? So this is a loop. It says for. For, of course, is an iterative thing. It means for every one of these values I give you, do a bunch of stuff, okay? So this is saying for I in sequence along files in year one. What's sequence along files in year one? What am I going to get if I run this?
Well, that'd be all the files, so maybe it's actually the data list object.
No,
He gets to get 1, 2, 3.
yeah, you should get 1, 2, 3, and that's fun. That's actually what we want. So you're dead on target with that. So what sequence along files in year one does is it takes files in year one, which contains these 3 elements, and all it does is say there's 1, 2, and 3 of them. So I'm gonna make 1, 2, and 3. We're just going to use this to conveniently iterate over stuff. So that's perfectly great. Okay. So what that means, okay, what does that mean exactly? If this is the number 1, 2, 3, what is this loop going to do every time it runs? What is the only thing that it's going to do?
It'll run the following code on each of the 1, 2, 3.
Yeah, it's just going to take I, and first it's going to replace it with 1. It's going to run all the code here. It's going to replace it with 2, run all the code. It's going to replace it with 3. It's going to run all the code. There's nothing after that, and it's going to stop. Okay, that's all the loop is going to do. I becomes 1, then 2, then 3. That's the only magic that's occurring. Okay, so if it helps you think about it when you all look at this, imagine when you write a loop like this, that this isn't an I, but it's just the number 1. Just imagine the first iteration, it's the number 1. So you could quite easily imagine here that this is what it's really running, is it's saying data list and then subset it to data list names 1. Oh, well, if we look at data list names, it's station data, trip data, and weather data. So data list names 1 is station data. So you could imagine this is basically just replacing this with station data on the first iteration of this loop, right? That's all it's doing. I'm gonna put it back. Okay, so I'm gonna break this into another line so it's a little easier to see what it's doing. So what's gonna say is assign to data list, say station data, whatever, assign to it the result of read CSV, paste 0, open data year 1, file list. So this is actually an I. Okay, so let's see what this is doing from the very sort of like center of the core of this. So first, file list. Oh, there is no file list. So what is file list and what should this be? Ah. Is it data list? Not quite. Ah, I like that one in chat. Files in year 1. Files in year 1 are the actual full file names, right? So 2015 station data.csv. Okay, I'm going to replace this with a 1 to see what it produces. So if I paste together the first element here, station data 2015 CSV with open data year 1, what am I missing? Let's run it and see. Ah, doesn't quite look like what we want. What is the one thing we're missing?
Slash.
Yes, we're missing a slash. I can just put it here. And then the first time it runs, it's going to produce this. Okay, so that actually looks pretty good. If I say read CSV this, and I can actually test it, it's going to give me the actual data is going to spit out here. So I've tested that. That looks like it works. So I'm going to delete that. I'm going to put I back here. Okay. So what this is going to do is it's going to read in that file, assign it to that location in data list. Then it's going to run to the next file and the next location, and then the next file and the next location. That's going to assign those things. Theoretically, if I haven't messed up anything in the process, I should be able to run this loop and it will get something like this. This is it loading in the first data frame, the second data frame, and the third data frame. Okay. So I should have something that looks like, I'm going to go structure on data list. You're going to see a lot of stuff. It's big, right? So what I'm seeing here is I have, if I look up here too, I have station data, trip data, and weather data. And within them, I have a whole bunch of columns all over the place. Okay, so here's the question here. If I have this loop, how have I erased my names? So let me see what your loop looks like. 1 to length data list. One length data list should be 3. That's from 1 to 3. Let's put in data list 1, read CSV, paste together, files in year 1. So the answer for that is you shouldn't lose your names. Station data, in fact, I don't lose the names. So the question here is it running this line up here at 53 when you run everything? Because I don't see anything there that should cut off your names. Or are you reassigning the list anywhere? Like, are you rerunning it or anything like that? Yeah, double check up there. Yeah, without overwriting the object in its entirety, you shouldn't be able to purge those names. Okay, so we've made a nice little loop that runs through this. Do we have more questions about this? Because the loops are complicated, right? As I've tried to hammer in, if you don't understand loops, that's okay. You are normal. If you do understand loops right away, good for you. Most people do not. Can you explain the slash again? Absolutely. So the thing is here, the original code that we had was basically this. If I run this code, the issue is that this is open data year 1 and then immediately 2015 election data.csv. Because there's no slash there, it doesn't know open data year 1 as a directory and that this is a file. It just thinks there's one big file named open data year 1 2015 station data CSV. The slash is just there to make sure it knows that this is a directory right there. That make sense?
Yes, thanks.
Okay. There's actually a fun little shortcut built into list.files that can take care of that. So if you go look at list.files like this, you could actually say, I think it's full.names equals, yeah, equals true. If I browse into open data year 1, it actually returns it with the full folder name here. So you can see full name's true. If I do full name's false, it's just the file names. But full name's true, it keeps the original open data year 1. So you could also use that. Okay. So here's a question. Can you go over the output one more time? I'm not sure I completely understand what we've done. We're just putting everything together. Kind of. So when you say the output, you mean what the loop is doing? Yes. Okay. Yeah, so the gist of it, right, is we originally had, I'll rerun the prior chunks and delete basically what I have up to now. So data list originally looks like this, right? Station data, trip data, and weather data. All I'm doing is having a loop, and that's what it's going to do is it's going to say, read CSV on the station data file on my computer and assign it to the station data location and data list, and then do that for trip data and then do it for weather data. So essentially all I'm really doing is saying, I'm just making a loop do like this for that's all the loop is doing. It's running 3 different read CSVs on, actually I would of course need these paste zeros here as well. I've broken something. Oh, I have not broken something. Okay. That's all this loop is doing, is it's running 3 different read CSV commands, sticking together the relevant path names. In this case, it's pretty easy and actually probably less effort to do in the read CSVs like this. If, however, you had a folder with 10, 50, or 100 of these CSV files, it would be a real nightmare to do this manually. So that's all that we're really doing. Does that make sense? Okay. Okay, so we've read this in. It looks pretty good. I'm not going to use the structure command there. Get rid of that. Okay, so what I'm going to do here, and is not required, is let's do this with another method. Okay, so I've shown you how to do it with a loop, and it's important to know how to do loops, but there's other ways to do it. What would be another better way I could do this? In the abstract, yeah, I could do it with lapply, right? So the lapply command is for applying something over a list of stuff, okay? So if I wanted to read in all of these data using an lapply, oh yeah, the lapply is going to lose your names. The reason for that is the lapply doesn't assign things to the original data list. It created an entirely new object. So if we want the names out of the lapply, we're going to have to do some craftiness or add the names in afterwards. Okay, makes perfect sense. So if I want to convert this loop here to an lapply, how might I go about doing that? Does anybody have an idea? There's a bunch of different ways we could do this. What are we going to iterate over in the lapply? So as in, what do we want to change each time we run this function we're going to make? What's the only thing that changes up here?
The index.
We can do it with the index. So here, our index, right? What's our index up here?
I.
Yeah, well, it's I, but what is the values it takes?
1, 2, 3.
Exactly. So I could just say, let's iterate over 1, 2, and 3. So I'm going to say, let's iterate over 1, 2, and 3. What must an lapply always use? What's in an lapply?
List.
Well, it makes a list, but what does it always run? Like, what is the content in it? How does it make things happen? So here, a loop, you just run a bunch of stuff inside here. Instead of doing a loop, what does the lapply have that it does over and over again?
Function.
Yeah, it runs a function. So I'm just going to say, let's run a function of x like suggested in chat, break out some brackets, and then this is where the magic is going to happen. Okay. So now I have to write some function in here, which takes the numbers 1, 2, or 3 and spits out the data frame I want. So what is that going to look like? What do I need to do? So what function am I going to run inside my function?
Read CSV.
Exactly. I'm going to read a CSV. And what am I going to be reading?
Same things before, right?
All right. Let's just take this. So this says, I want to read CSV. The file path I want to read is open data year 1 / files in year 1. What do I need to change I to? Yeah, I can change it to X here. So this is just going to make it 1 and then 2 and then 3 and read this all in. Because all this is doing is saying, take the numbers 1, 2, and 3 and one by one replace or send them to X here. And this X replaces the X inside. So this is just going to iterate over 1 and then 2 and then 3. So I'm going to say, and it just did the exact same thing as our loop. Okay. So it iterated over it, but I didn't have to write nearly as much stuff. I didn't even do any of this. Notice the entire assignment thing on the left side of the loop didn't need to be done. You don't need it because it's actually being done right here. All the assignment is actually happening to the data list 2 object. If I look at this, it's the exact same thing we spit out before, but there's one notable difference. Because we created a fresh data list, it doesn't have the names we wanted. So if we wanted to get the names, I could literally say, assign the names, and now it's going to have station data and all that kind of stuff. So I would just do the names afterwards.
Why did we have to pre-allocate for the loop, but we could make it on the fly with lapply?
So this is the wonderful thing here. So the issue with the loop is you'll notice the loop is doing its assignment to the sub-element of the object data list. Well, we do the pre-allocation so that data list exists in the first place because we need something to assign to, like there will be no location. I can't assign to, let's just say, I want to assign to the first element of gibberish here. There's no object gibberish to assign to. Our pre-allocation creates this initial object. The thing is here with the lapply, the neat thing with an lapply is it runs all this code. It essentially puts a list in memory, and then you can assign it because the entire object has been created. Like anything else, if you've created an entire vector or something, it's essentially like saying, because we're making the whole object and assigning it to the top level of it rather than assigning it to some subset of it like this, it'll work. So I can't do this line on 67, but I can do the line below it, right? I can't do this because there's no gibberish object to subset to, but I can assign to gibberish 10101 because I can create the object like that. The issue is this thing up here doesn't create the underlying object. And that's actually what the loop is doing, is subsetting. Yeah. lapply is nice because lapply takes care of all that pre-allocation business. Yeah. Here's a great question. I've noticed your R has fancy colors for each set of parentheses or brackets, which makes it nice to check for missings. How do you do this? I tried changing appearance, but it's not working. Yeah, it's not actually in the released version of RStudio. If you want to get the version of RStudio I'm using, which is 1.4, so if you go up into help and say about RStudio, your version is probably not 1.4 point something. It's probably 1.3. You can go and download the version of RStudio that I have by Googling RStudio Preview. And the RStudio Preview edition, which is actually newer than the one I have, has the fancy colored brackets, which make it a lot easier to look for missing brackets. So these ones sometimes are unstable because they're experimental versions. Honestly, I've almost never had one that didn't work perfectly fine. But you'll see here, this preview contains workbench productivity improvements, including rainbow parentheses. Rainbow parentheses are freaking awesome. And so I was really happy about that. Makes it so much easier to see how things match. Okay, so these are equally valid ways of doing it, but 9 times out of 10, I would do it the lapply way rather than the loop way. And in fact, I'm so used to doing the lapply ways that I frequently forget how to do things with loops nowadays, just because the lapply is so much better way to do it. Okay, does everybody remember the one even easier way to do this than lapply? Vroom, beautiful Vroom. I could say, let's load up the Vroom library. And this is all I need to do. I'm going to say, I don't need to do that. So I also need to do one tricky thing with Vroom, which I'm pretty sure has an option for. Let's see. Where is it? By default, Vroom reads in data frames and sticks them in, or reads in files and reads them into a single data frame, but we want a list as output. And I think there's a way to make Vroom do that, but I can't remember what it is. Oh, actually, it looks like they don't have that functionality in Vroom. So never mind. I feel like Vroom used to be able to do that. Okay, well, the lapply then is the easiest way to do this. Yeah, I thought Vroom had a way to read straight to a list, but apparently not. Never mind.
That's really surprising.
Yeah, it is kind of funny, but when I think about it hard, it actually kind of makes sense because the point of Vroom is specifically to read in and work like data frames in a tidyverse framework. And since tidyverse doesn't like loading things into a list, it kind of makes sense. The tidy way to do that and produce a list would be to use the purr package. I don't teach purr in my class because I honestly don't think it really does much that lapply doesn't do, and it has some confusing syntax, but you could do it with the purr package with map. Why do we use paste 0 here? With paste 0, it just says take open data year 1 and the files in data year 1 and stick them together. We need this because if I don't do paste 0, read CSE will think these are 2 different arguments. So I'll copy this here. So without paste 0, we'd essentially have this. And what this is going to say to read CSV is I want to read CSV this file, and then it's going to expect this is the second argument to the function. When what we actually want to do is we want to give it a full file. And so by pasting them together, it turns it into a single character element. Oh, that's paste 0. 1 character element, so a single argument.
That's helpful. Thank you. So in the bracket after it says way, it is the location of the file. Is that right?
So on what now?
I mean, the open data year 1.
Yeah.
Is that Is this a location of a file?
Yeah, so if I go to the actual folder, so right now I'm using this homework 6 RMD file here, which is kind of hard to see probably. And the open data year 1 folder is this folder up here. And so it's literally just saying, go look for a folder named open data year 1. The slash basically indicates open that folder, and then inside of it, look for the files in there.
Thank you.
Yeah. Next one. How would we add our list names again if we used lapply? This right here, the exact syntax we used earlier on our pre-allocated data frame, we actually just assign the names afterward. You could technically do it all in one step if you really wanted to, using something like set names, data list names like that. This would say run the lapply, read in all those files, send it to set names, and assign these particular names. So you could absolutely just do it in one step, but I think it's clearer to do it like this and just assign them afterwards. Okay. That makes sense? Sweet.
Yeah.
Okay. Any other questions before I move on? Now's the easy stuff from here on out. Good beans. Okay. So I say here, and I already did this, run structure on data list and look at how the variables came in using read CSV. Most of them should be okay, but some of the dates and times might be stored as character data rather than dates or POSIX time values. We also have a lot of missing values for gender in the trip data because users who are not annual members do not report gender. So what we're going to do is we're going to fix these little errors in our data. And I can actually, I'll show you this right here. So if I do structure, data list. Oh, I got to rerun this. Okay. Structure, data list. Okay. So in these data here, station data, that's fine. That's not time varying data. Everything looks fine here. I go into trip data over here, and we see like start time here is character data, and it looks like 10/13/2014, 10/31. We want to convert text like this into date time data. So we're going to do that in a second. And another thing we want to do, for instance, is we see here that there's this gender column. We actually don't see any missing data here. But if I pull out some examples, I can say, so if I want to get just my trip data out of here, what should I do? If I want to look at data lists, but specifically the data frame for trip data, what should I do?
Extract trip data.
Sure, that's one way to do it. So this will give me only the trip data frame, which looks like a conventional sort of nice data frame. I could then say, let's take a quick peek at the gender column. Oh, I can't find count. What do I got to do? Yep. Load dplyr. Now I can see that for the gender variable, there's female here, male here, other, and a whole bunch of NAs. Okay. And the thing I hint at up here is that if a user is a short-term pass holder, gender doesn't get recorded. So if I do a cross tab of gender and user type, we can see here that for user type, everyone with a valid gender value is an annual member, and every person with an NA for gender is a short-term pass holder. So basically what we want to do here is we just want to replace all of these short-term pass holder users, their value of gender with unknown, okay, which we'll do here in a second. So basically those are our two main things we want to do. We're going to fix our dates, and we're going to fix this particular column so we can use it later. Okay. So if I want to fix these gender values so that anytime the user type is short-term pass holder, gender is unknown, how might I go about doing it?
If else?
We could do it with an if else. So what am I going to start with to get it down to that point where we start with an if else?
Oh, wait, is there a way to do it with indexing from the short-term pass holder cost tabs that you just did?
There's different ways we could do it. I would probably do it with the if else. I'll tell you now, but we could do all sorts of funky things. I'd say, well, okay, there's one really easy way that is not even using the user type, because you'll notice that since the NA is always when it's a short-term pass holder, we don't even need to subset on it, and we can just replace the NAs. But let's do it with the short-term pass holder. If I want to work on the trip data frame, what do I got to do first? This is open to anyone, of course, and not like specifically. So we could use filter, but how do I get at it? So what am I going to be filtering from? So right, I've got data list. There's two different ways I can pull out the thing that I want. We've seen one of them. What would be the other way I could pull out the trip data out of here? Percentian will not help us here. If I want to extract the trip data, but not use the $sign, what else could I do? That I remember? Two ways to subset a list. Not a pipe. We will pipe in a minute. I like brackets, specifically the two brackets. Double brackets, and then what do I want to put inside of them? What goes inside? So brackets let us subset using, technically I could use numbers, but what's the better way to do it? I could do it with numbers, but what would be if we rearrange? There we go. So the thing with the numbers is in case we rearrange our data frame, it might muck things up. But the nice thing is with double brackets, I can say extract the trip data. This right here, double bracket with the word inside, is actually what the $sign is really doing. It's basically converting this trip data into this text and running double brackets on it. So anytime you see the $sign, this is what's technically actually doing, but it doesn't look like it. These are equivalent. It's actually, this is a shortcut for this operation down here. Okay. So this gives us our trip data. So earlier, it was suggested that we're going to use a filter. I like that. If we want to just update or modify the gender column, what should I do? Oh, sorry, filter. No, we shouldn't use a filter. We should use a mutate. Mutate, not filter. Mutate for making variables. Should have made people tell me what that one was, but I corrected it on my. So if we're going to modify the gender column, what should we do? How do you modify things in R? Yeah, name or new variable, but here we still call it gender. So the idea in R is making a new variable and modifying an existing one are the same operation, because modifying something is actually just destroying it and replacing it with a new version. So it's just like creating a new variable, you just overwrite it. Okay, so mutate both modifies and creates new variables. It's an identical operation. R is a destructive language. Okay, so Tristram suggested earlier that we can do this with an if else. I like that. So we're going to say we're going to modify the values of this gender variable, and I can show you again the relationship we're looking at. How would I set this up so that gender will be replaced with the value unknown whenever it's a short-term pass holder, but leave it alone otherwise? So what's the very first part of an if-else statement? What's going to go here?
Is there not a function that's just like is empty?
Oh yeah, you can do like it's not so much is empty, but it'd be like you can do an is.na and you can just swap it. There's actually a data frame level replace NA also. I want to do it with the if else here. So, but I'll show you another way to do it in a second. So what is the first argument to if else? I could say question mark if else. Yeah, I like that. That's actually dead on right there. It takes a test or a logical value as its first argument. In this case, it's going to say if the user type is equal to short-term pass holder, I want to do something. So if it is short-term pass holder, what do we want to assign to gender?
Unknown.
I like that. Unknown. I'm going to capitalize it because that's what I say up here in the text. Now, if we want to leave gender alone, what do we want in the second value? What do we want it to do when the user type is not short-term pass holder? How do we make it do nothing? If we do this, it's going to overwrite all the other values with blank. So we don't want that. We want it to be the same old values. But we have to give it something. How do we make it give it the old values everywhere else? Now that would give us the user type. What do we want this gender value to take if it's not a short-term pass holder?
Gender.
Yeah, this is some sort of a funny thing which takes a minute to wrap your brain around. If we replace gender, what this statement is saying here is when the user type is short-term pass holder, gender should be unknown. But if it is not short-term pass holder, it should be gender. Because what it's going to do is it's going to grab the original values of gender and assign them over here before it overwrites itself. So this is essentially just saying keep the values of gender exactly the same. We did this with my Czechoslovakia or my former Slovakia, Yugoslavian ones back in week 3 with an if-else statement. Okay, so if I do this, I can look over here at gender, and if I scroll down enough, we should see there's one. Short-term pass holder is now gender unknown. Okay, so that seems to have replaced our values. That works. Now, I've done this change here, but I haven't saved what I've done. You notice I've just said data list, trip data, and then mutate. If I don't assign it to something, it just does it, displays it, and doesn't write this back. How would I write this back and save my changes to trip data? How do I have to modify this? Because R doesn't change things in place. You have to be explicit. There we go. Not just to data lists, though. What do I got to do? So I'm modifying not just all of data list, but I'm specifically modifying the trip data. Yep. So this is something about R. If you want to modify an object, you generally are expecting to see some sort of symmetry here. So the thing that you start with here should be the same thing you're assigning to. If these things look the same, you're probably doing some sort of modification operation. So in this case, I'm basically saying, we're going to start with this thing, do some operations to it, and then assign it back to what I started with. Okay. So that makes that one change. Okay. So we've effectively fixed our gender variable, and we've written it back. I'm going to do that. And now, if I take this exact same operation I did here, we will now see that the short-term pass holders all have unknown gender. We have no missing values. So we have fixed our little problem that we had before. Okay. So I think we only have one other thing we need to do. Yeah. So the next thing we need to do is I need to fix the dates and times in the trip data. I think it's only in the trip data and the trip data and the weather data. I'm going to take a quick look at the data. I'm going to say, actually, why don't I just go like this? Here's another thing we can do. I can say data list trip data. I'm going to send this to a quick glimpse. Take a quick look at my data. So the glimpse function in dplyr is like a superior structure function, but it only works on data frames. So I had to extract the trip data from data list first, and now I can take a peek. So if we remember, we want to fix these dates and times. So start time and stop time. We're going to fix these with lubridate. I'm also going to take a quick look at the weather data and see if it looks okay. The weather data has a date column, but it's character data instead of a proper date. So we want to fix the dates and weather data and the date times in trip data here. Okay, we're going to fix them both. Now, if I want to change start time and stop time, these two variables, how am I going to go about doing that? What is the very first thing I want to do if I'm going to pull out the trip data and work with them? What do we start with like usual? Yep. Boom. We begin with a data list, trip data. Okay. Next thing we want to do is if we're modifying a variable, what do we always modify variables with? We just did it a minute ago. We're modifying start time and stop time. We're going to mutate. Now you'll notice here I said we could use mutate at, and that's because I forgot to modify this template. The mutate at function is no longer the way to do multiple variables. It works if you're used to it, you've used it before, but it's not what I'm going to teach in the class. We're still going to use mutate. If I want to mutate two variables the same way simultaneously, do we remember how we do that in mutate? It's a helper function you can use inside mutate to use multiple variables at once. Anybody remember what it is? C is part of it, but there's another function we'll use that inside. I like it. Mutate across. So this says we're going to move across multiple variables. Okay. So now's where the C comes into play. So we can say, I want to mutate across. What variables am I mutating across? What am I doing? We're fixing the dates and the times. What are those columns? They are start time and they are stop time, which I'm going to copy and paste straight from chat. Maximum laziness. Okay. So this says I'm going to mutate across these two variables. And then to those two variables, I want to do something to them. I suggest up here that we should use probably, or do I suggest it down here? Yeah, we should use functions from the lubridate package to do this. So if I want to use something from the lubridate package, what should I do? Yeah. I'm going to load lubridate. Now, if I have data that look like this, 1013, 2014, 1031, do we remember the kind of function in lubridate we're going to use to convert this to a date time? What do those functions look like? Do you remember their intuitive syntax? Yeah. So this looks to me like a month. This looks like a day. This looks like a year. The nice thing about these data is it's for once unambiguous what they are because there's no 13th month. So month, day, year. hour of the day, minute. There's no AM, PM on here. So we're going to let Lubridate figure this out for us. MDY HM. Okay. This may actually work like that. Yeah, it does. Okay. So you don't necessarily, if you're using a function and not giving it any options at all, you can just name the function right here. But other times you've seen me write this like this. The reason to write it with the tilde and the period is in case you have to add more arguments to it in here, but you don't have to do it. That'll work just fine. So what this says here is I want to mutate. I want to mutate multiple variables at the same time. The variables are start time and stop time. And the way I want to mutate them is with the MDYHM function. If I run this, the data that pop out, start time and stop time, are now POSIX CT date time objects, if you remember when I gibbered about that a little bit. And now you'll see the date is in a format an adult would come up with, where it begins with the thing that changes slowly, year to the month to the day, then hour, minute, and second, right? This is a logical ISO standard type time. This looks nice, okay? So this is how we want our date times. They're now a type of numeric data that we can do operations with instead of character data. If I want to save these changes I made back to my original data, how would I do that? Yeah, we're going to assign it back. Okay. We fixed our trip data. If I glimpse at them again now, we can see our start time and our stop time are a DTTM object. They are a date time object, and they're looking good. Okay, so we have one other thing we want to do. Actually, no, we have two other things we want to do. I also want to, in the weather data, I want to fix these dates and make them a proper date. Okay, how would I adapt this code here for the weather data? In fact, I'm literally just going to copy and paste this. Tell me what I need to change to make this code work for my weather data. So what's got to change here? Yeah, change all the trips to weathers. Like that. Okay. What's the next thing I need to do? Top line's looking good. Let's modify all this stuff in here. So let's start with this. How many variables are we modifying? We only got one. So what do I not need, right? I'm only working with one variable, so I probably don't need to use a cross. I'm not going to cross multiple variables. So what should I replace all this stuff with? Yeah, I like that. So we'll begin here. I'm going to delete everything in here. Well, I'll leave the MDY HM. So we're going to begin with date here. So what do I got to do next in Mutate? I don't want to just do an MDY and a comma here, because then it thinks there's some variable here and some variable over here, and I don't know what the hell to do with them. So what do I do instead? What am I going to say? I'm modifying a single variable. Not so much function, but just the equals. I'm happy with the equals. And you're dead on right about we remove the underscore H and M, right? So the idea here is that it's not month, day, year, hour, minute data. This is month, day, year. There's no hour, minute. So the Lubridate function is just MDY, because Lubridate is nice like that. What we're saying is we want to convert date equals MDY, but I don't just want MDY. What do I need to tell MDY I'm doing? Because it's a function, right? What do I gotta say? What are we getting? Yeah. MDY of the date column, and we're going to overwrite date with that. If I run this, assume I didn't type anything wrong, get glimpse. Date here is now a date data type, and it's again in adults format of year, month, and day. Okay. So there we go. We've cleaned up our two dates. That's exactly what I was hoping somebody would ask. Why do you have to put anything in the function above for the start-stop time? Yes, this is fun syntax here. It's implied by what's going on. So this is saying we're going to mutate. We're going to run across two different variables. Because I've said across and start time, stop time, to across, I have implied that these two variables are going to be the arguments to MDYHM. So across lets us play with shortcuts like this. This is actually the equivalent of instead writing, I could instead say, start time, stop time equals. Okay, so this across syntax like this is a shortcut for doing this. It's a way to save us some typing, but it's actually taking care of filling these things in for us to save us a little bit of time.
What library is across?
dplyr. If you don't have it in your dplyr, you have an outdated dplyr. It was added in dplyr 1.0. Try and keep my class cutting edge. Did that make sense there, Anna? Or do you need you?
Yeah, now that's clear. Thanks.
Yeah, okay. Yeah, it's kind of like, it's a little weird, right? It's some saves. Okay, I run into an error, all formats failed to parse, no formats found. Ah, I will get that error too if I try and run this a second time. All in failed to parse, no formats found. The reason for this is the first time you run this, it converts the character data to a date time. If you attempt to run this again, it's trying to convert a numeric date time object to a date again, and it fails. So you can only run this line once. What's happened is you've tried to run it a second time. To fix that, click this little button up here to rerun all the code above, and then you'll be able to run it again. Does that make sense? So the dumb thing about lubridate is that if you attempt to run lubridate functions on an existing date time object, they kick an error out and overwrite the variable, which is very stupid, but I have no idea why they haven't turned in added something to prevent them from doing it.
What version did you say it was added in?
1.0.0. Or is that 3.0? 1.0. No, it's 1.0. Or let me check my dplyr. Yeah, I have 1.0.0.
I'm on 1.4.2.
dplyr 1.4.2?
Oh, sorry, that's dbplyr.
Yeah. Yeah, it should be. It's in 1.0. It was a big deal when it got released. I added across because they popped it out. It's been almost a year, I guess, since dplyr 1.0 came out. I updated these slides for it in spring. Also a problem in running mutate to fix the gender variable. Well, show me the code you've used to do that, because that's what we're about to do. There we go. Oh, the gender variable. We haven't changed it to effect. So inputting gender is if else user type. You need 2 equal signs instead of 1 after user type. It's a logical test rather than an assignment. Sneaky. It's one of the most common errors. Yeah, I do that all the time myself. If I had a nickel for every time I used one equal sign instead of two, I'd probably have literal dollars. Be a wealthy man. Okay, we got one last thing we need to do unless anybody's stuck on anything else. Anybody stuck on anything? We're going to do a technically unnecessary thing, but it's in the homework, so we're going to do it. So what I want to do is I want to convert let's see, user type and gender variables to factor variables in the trip data. How might I do that? I'm going to convert over multiple variables. I want to turn them both into factors. How could I add something to this statement up here since I'm already working with the trip data to make that happen? If you're clever, you can do it inside of the same mutate command even. What should I do? I want to modify user type and gender into factors. Any suggestions? Starting points? Here we go. As factor, but don't know where. Yep, that's a good starting point. The next one, we could use a user type equals factor user type. I like it. So I'll show you two ways to do this because that's correct. I'm literally just going to copy and paste. Multiple people are dead on. We could do it like this and say user type and gender, right? We could do it this way and convert them both into factors. But how could we do this another way? So we could do this with a cross, right? Which I think is what Courtney was suggesting, possibly. So how could I mimic this syntax up here and use it for user type, gender, and factor? How might I modify that? I got anything? So we've got, yeah, that was good to me. So this is essentially the exact same syntax as before. This is saying I want to mutate across the user type and gender columns. The way I want to do it is convert them to factors. Okay, you got an extra parenthesis there. Okay, I'm going to rerun all my stuff beforehand. And then I'm just going to say, let's do all that. Now I'm going to take a quick glimpse at my trip data, and we will see user type and gender have been converted to factors, and our date times are still good. So I've just done it all in one step and in one big mutate command. Okay. Break these up into their own chunks. Okay. That after. Okay. That's all I wanted for this first part of this homework. That's the entirety of part one. So, do you have any questions? There is one very hard thing on this first part, which is basically the loop, and the rest of it is meant to be sort of like not too bad. Earlier, did you mention you shouldn't load libraries? Yes, do not load libraries where there is a cache equals true chunk option, because it will only run that chunk the first time you run it, and then after that, it doesn't run it again, meaning it doesn't load the libraries for later use. There's some other chaos that can ensue if you do chunk equals true. A common one is if you cache an object that depends on a package, but you don't load that package somewhere, it won't be able to load the cached chunk. So caches do weird shit sometimes. I recommend only using them for purposes like this, when you have some fully contained thing, you're loading some data. Here, I have library reader here. This is bad. It's going to actually fail to knit the second time I knit it. It'll probably work the first time, and then it will fail the second time. So if I knit, it's probably going to be like, oh, I'm happy to work. Now it might fail the second time, but not necessarily, depending on what's going on. Yep, there it goes. The second time I knit, I literally did the exact same thing. It doesn't work, okay? Because it can't find the function read CSV. The reason is that it never loaded the library because it tried to pull it out of cache. So here's an example where if I want to do that, library reader needs to go, higher up, maybe, this is why I usually like to have a setup chunk at the top like this. I'll usually call this setup and do include equals false. And I would load my stuff up here at the top. This is what I consider good practice in an RMD. This will solve all my problems. Now, not all of my problems. I have a lot of problems, but it will solve that one. Okay, knit it once. I can knit it again. Everything's dandy and it works fine. Okay. Anything else?
I have a quick question again about writing the loop.
Yeah.
So when we have paste 0 and we're opening the file, like the files in year 1, I mean, I guess those are the files, but aren't you basically telling that file, like each of those files, to populate into the list, right?
So yeah, I basically what I'm saying here is I'm assembling together a directory location, which read CSV reads and browses to that location and grabs the file, and then read CSV spits out the file into this part of the data list. Is that what you're asking?
Yeah, I guess I was just confused that you didn't have to like say each of the files, but I guess that's the length of I, right?
Yeah, and so the idea with the I is that it's basically files in year 1 is being, in each iteration, it's first being replaced with this, then this, then this. So it's actually iterating through those file names for you.
Okay.
Yeah. Okay. Next one here. Unexpected symbol in data list. Unexpected symbol is usually a missing parenthesis. So I'm going to copy this right here and see what that looks like. I'm going to scroll down to here. Let's put it right here. Yep, you're missing a parenthesis right here. And also you probably don't want the parentheses on as factor. So you want it like that. Does that make sense?
Okay, thanks.
Okay. Next one, when I go to knit, I'm getting the error on line 78, use method mutate, 78. Is your 78 roughly the same as my 78? Is it like this one? Okay. So couple things. Can you paste in your code you have there that's a little bit above and below it, above 78? Because it might not be given the exact location. Okay, so it can't be that one generating it because there's no mutate call. So it's got to be the stuff that's kind of down where there was a mutate. So go down to the next chunk you've got and give me your code in the next chunk. The line number might be slightly off,
And
but
just
it's definitely.
so when it says line 78, that's not a precise thing. It's like could be in that chunk of code.
Yeah, it's probably saying that the error, so I would imagine 78 is actually something like this first line of the chunk where the error is in. It should
Okay.
be lined up approximately.
There's this one. Okay. Let's see if that. Oh, sorry, you get my note in there. But
Yeah,
let me get
that's
rid
great.
of that.
Yeah, okay, so. Okay, that actually looks fine. So let me see. Oh, Atlas. Okay. Yep, that's working perfectly fine for me. So what is above that?
There's nothing with mutate above that.
Is there, you've loaded the library because the pipes are working.
Exactly.
Is data list trip data here? Does it look like the proper data frame?
Oh, I used, well, here, up right above it is this code, which I use the money symbol instead, but
Yeah, that's fine because that's not rewriting it back because I've got that up here. That's not modifying anything, should be fine. So if you're getting that on a knit, use method mutate. What's the rest of the error actually?
no applicable method for mutate applied to the object of class null calls anonymous and then
Okay.
going.
So what that is saying is that your data list trep data here is actually a null object. In other words, the data hasn't been read in. So the issue is probably up here in the loop.
Okay.
And check and make sure that when this loop runs, it's outputting the actual data list with all the data in it. So I would run the chunk and like run this chunk here. And I'm going to delete this really quick. If you run this chunk here, make sure it's popping out the correct data list and that it's not just containing nulls.
So the output should look like your screen now. Is that
Yeah,
right?
with a whole bunch of crap.
Yeah, no, it's going. Okay, maybe it just got stuck. Let me try again.
Yeah, knit again, see if you get that same error.
Hmm.
If you
Okay.
do, you want to make sure that the code above it is fine, in which case you can just send me the RMD and I can look at
Yeah, I'm still getting it. All right, maybe, yeah, I'm gonna.
it. Yeah, email me the RMD.
Awesome, thank you so much. Appreciate
Absolutely.
it.
Oh, that's a good question. Should we hide all the output for the knitted HTML? Only hide output. Don't put anything massive in there. Like don't put the result probably of the structure command on the entire data list, but otherwise show all the code. Okay, anybody else got anything?
Thanks again for going over this.
Yeah, of course.
Remembering how to subset correctly for the list almost had me in tears. So
Yeah, no, don't get to that point. As always, Slack channel or email, unless you learn from trauma like I do, in which case it's okay to do that to yourself.
a little bit. I mean, I'll never forget now.
Yeah, that's my idea. The reason I remember all this stuff is I torture myself because I'm unwilling to ask people, and so have to teach myself how to do everything.
Yeah, I think my partner's a little frustrated with how much I swore at the computer that night, but I've emerged from it a better person, I hope.
Yeah, no, I do that too. I'll sit here be like yelling about something, and my partner will also be like, just take a break. I'm like, no, I must learn.
Yeah, it has to be right now, not
Yeah.
tomorrow.
Exactly. I can't stop looking at it. So here's another question. Do you advise us to load all libraries at the beginning of the code? In actual projects, yeah. My general belief is you should load all the libraries in the top setup chunk in an RMD or the top of a script. I don't like loading libraries midway through a document. If you need to use a library like once and you want to load it midway through, I say don't load the library at all, but call on it using the double colon operator. Kind of like, if you want to get something like out of the mass package, you do something like, for instance, running a negative binomial model, I would do it this way with colon, so I don't have to load the library. Everything else I would load in a setup chunk. I didn't do it this time because I wanted to draw it out at people as we were going.
Thank you.
Okay, folks. I will see folks on Wednesday. Shoot me messages, Slack channel, email if you're on any problems. Okay.